What's up YouTube? I'm Digital Andrew and welcome to my lab. In today's video, I'm going to be teaching you how to do chip off firmware extraction. My intention for this video is that it will be like a mini course. I'm going to show all of the steps, everything you need to know. I won't skip anything. I'll show you all of the equipment that you're going to need. And my intention for this video is that by the end of it, you'll be able to follow along and do this yourself or reference back and follow the steps. We're gonna hop over to the lab here in a second and get started, but before we do, let's chat quickly about the difference between in-circuit firmware extraction and chip off, and why we may need to actually do chip off firmware extraction. So if you've taken my IoT and hardware hacking course, the beginner one, then we did cover some firmware extraction in that, except we did it in circuit. So we used a chip clip like this one or IC test pins to actually clip onto the leads of the flash memory in the circuit. And then we were able to actually just perform a read of the firmware successfully doing that. And sometimes this will work, but sometimes this actually won't work or it's not possible to do. And in these scenarios, we're going to need to do chip off firmware extraction. So the main two reasons that this won't work is number one, you're working with a chip package, like for example, this WSON 8 here, or maybe even bigger ones like TSOP packages, where the pins are not really accessible and it's not realistic for us to be able to actually access them in circuit. So we've got to take the chip off in that scenario. The second one is sometimes even with these SOP8 or DIP8 packages where we do have access to the pins and it is realistic for us to connect to them, we still cannot perform an in-circuit read because either the device or the circuit is interfering with that read. One of the main reasons this can happen is because of VCC backfeeding. So when we connect our programmer up to the chip, of course, we have to power it through the VCC pin, and that pin is actually then connected to the VCC rail in the rest of the circuit. So we can actually sometimes supply enough power that the device tries to start on, and then it tries to actually read from the flash chip as well. And we're fighting over it with the programmer. And this is going to cause our reads to fail. There can also just be other things in the circuit that interfere with it, like pull up or pull down resistors, or even just the internal resistance of the circuit itself. So in these scenarios as well, we'll need to pull the chip off or at least lift up some of its legs to do a read. In my opinion, if you're going to start lifting up legs, it's probably easier just to take the whole chip off. And that's what we're going to take a look at in this video. So let's hop over now and take a look at the equipment that you'll need and everything you'll need to do this, or at least what I use. Before we do that, a really quick disclaimer, I will say there are lots of other different ways to do this, and there may be steps that I do that you could potentially skip or steps that some people add. What I'm going to be showing is what I've always done and has worked well for me. With that being said, let's hop over to the workbench now and take a look. The first item you'll need is a hot air rework station. So this is what we're going to use to actually melt the solder and be able to pull it off of the chip. I use this LRT 858D. I think I got it off of AliExpress or Amazon for pretty cheap. And honestly, I've had this for a while and it works just fine. So I'll drop a link to this and everything down below. They're not affiliate links, but just to make it easier for you to find. But yeah, you don't need to go overboard on this one. This is a relatively inexpensive one. And honestly, I've had no issues with it and it works great. The next thing you'll need is some flux. I like this MG Chemicals 8341 no clean flux paste. It comes in a syringe, which makes it really easy to apply for these surface mount reworks or chip off extractions. So again, this is one I recommend here, the one that I use at least, and it's worked well for me. You're going to need a pair of tweezers, preferably an ESD safe one, because this is what we're going to use to pull the chip actually off when it's hot. You're not going to want to be touching that with your hands. I'm going to be using some heat-resistant masking tape. You'll also hear this referred to frequently as Clapton tape. This step is optional, but it's nice to be able to protect some of the other components if you want that you're not working on. So I like to use this one. It's optional. You'll usually see this sold as Clapton tape or heat-resistant masking tape. For cleanup, you will need some isopropyl alcohol. I use this one for MG Chemical 7030 isopropyl alcohol. And I like to put it in these little squirt bottles for easier application. And then for some cleanup, it is nice to have a Q-tip as well. Once we get the chip off, to actually read it, I'm going to be using my Xgeku T56. Again, you could be using the T48 or honestly different readers as well, but this is one of the most popular ones and is a very universal one. And I'll be showing how to use this and some open source software later on. And then you're also going to need an adapter. So I've got one here for a SOP 8 chip, which is what we're going to be working with, is the SOP 8 one. And you'll need a whole bunch of different adapters here if you're going to be wanting to do chip off firmware extraction for all of the different packages. So you can get these in packs. It's good to get a whole assortment of them. If you want to be able to attach the chip on back afterwards, you're going to need a soldering iron. I've been rocking this Pine Sill now for a while and I really like it, but I mean, really any soldering iron with a fine point is going to work. And then, of course, going to need some solder. I like this lead solder, and you'll also need some copper here, some of this copper wicking tool to be able to pull away the old solder. So in this video, we're just going to be going over how to take the chip off and extract the firmware. And then there's going to be a part 2 actually to this where we'll take a look at putting the chip back on. So I just want to call that out in case you want to follow along with that as well. And then last but definitely not least, I will just bring it to frame here. I 100% recommend you use some sort of extraction or very good ventilation when you're doing soldering, especially surface mount soldering, so you're not breathing in all of the fumes. I like this Hacko FA400 one here, but really anything, any of the solder extractors can work well as long as you see it's pulling away the air. Finally, we're going to need a target to work off of because I have a whole bunch of them lying around. I'm going to be working off of the TP-Link router that I used in the IoT hacking course, but really you can use any chip or any device that you have that you want to go ahead and extract firmware for. This is really going to work for pretty much all of the packages as long as you have an adapter and you're patient with pulling them off. And just because I get asked a lot about this, this is the PC Byte stand and the PCB holders from that. You definitely don't need these. You could honestly probably just rest this on an anti-static mat or a soldering mat or use a third hand or anything like that. I just really like this one because it holds it in place so well, but this is definitely 100% optional. I will put a link down to this below as well because I get asked a lot about this. So I'm ready to start getting the board prepped here to do the chip off firmware extraction. And I should also quickly call out, so this is the flash chip right here that we're going to be trying to pull off. If you zoom in on this even more, you can see some markings on it and then look up the data sheet and you'll be able to identify that's what it is if you are not certain of it. And this one is in a nice SOP or SOIC 8 package, which makes it honestly pretty easy to pull this off. So the reason that we're going to be adding masking tape is these are actually like even really small to see zoomed out, but we've got all of these surface mount components right here, tiny little resistors and capacitors, and those can easily just come loose and blow off when we're trying to extract the chip with the hot air. So I usually like to mask them. Again, you can just be really careful. Sometimes you won't knock them off, but I think it's worth masking it. So what I'm going to do is I'm just going to apply some masking tape up the sides and all around here. Okay, I've got my masking tape on, and the one thing I want to really quickly call out is it is important to make sure you don't cover up any of these leads or any of the pads for them, because then you won't be able to heat them up enough to get the solder to melt to pull off this chip. Before I add any flux, I'm going to do an optional step here, which is to heat up the whole area around the board, and I'm going to use my hot air rework station for that. Alternatively, a better option actually is probably to use a hot plate or a hot workstation like that where we heat the whole board from the other side, but I don't have one of those, so I'll show you how to do it with the hot air rework station. So I'm going to set mine for this step to about 120 degrees. And then what I'm going to do is we'll just bring it over here, and we're going to come from pretty far away here with the tip of it. So just to show you what it looks like, actually, I got my hot air tip here, and we'll just come at it from, about 2 inches. And I'm just going to go in circles. And we're really not looking to melt any solder or anything here. We just want to warm up the whole board area. For me, it's winter here in Canada right now, so my office is a little cold. Everything's probably a little bit cold. We'll just try and bring it up a little bit to temp. It's going to prevent things from cracking or warping. And also, sometimes you'll have ground planes on these devices that are underneath the flash chips, or the ground, or there's a ground plane on flash chips. If you have that and those are cold, it's going to be really hard to pull those off. It's going to take a long time. So I'm going to speed through this here so you don't have to watch me do this. I'm probably going to do this for like maybe 5 minutes or so just to get everything warmed up and up to temp. Again, this is optional, but I like doing it. So speed through the rest of it. Okay, my board is nice and hot, so we're going to flux here and we're going to apply it. So we just don't want to put too much here, but we are going to put some. Again, the idea here is we're just going to put it where the solder joints are. So we're going to be putting it along these legs here. Put a nice little line here, squeeze it out. Honestly, that's maybe a little bit too much, but oh well. It's kind of hard to film and work around this, but we're going to put some over here too. Yeah, that's probably a better amount right there. A little bit of flux. And then now I'm actually going to crank up my hot air rework station to about 340 degrees Celsius. A good range for this is usually going to be around 320 to 360. So I'm going to start around 340 here. If you go too hot, you risk burning stuff or melting the chip or things like that. So I also got my tweezers here. So what we're going to be doing, just actually to explain before we get into here, is I'm going to be coming in with the tweezers, and I'm just going to be trying to gently lift up on this. We don't want to be doing any prying or, really working at it. It should just lift off very gently on its own, because if we put too much force, then what's going to happen is we're going to damage these pads, and then it'll be hard for us, or impossible for us, to reattach this chip. So again, good to go slow and don't force it. Be patient with this. So now I'm going to come much closer to the chip here, and I'm just going to work in circles here. See, the flux is melting. And at first, I'm not even going to be worrying about touching the chip. I'll keep my tweezers off, and we'll just wait till it's heated up a bit, and grab it here. You can see, so mine's still no luck here. Again, so we'll just give it a little bit longer here. So again, the goal here is nice and low and slow, and we can see now it just lifts right off, and we get our chip lifted off with no real damage to the pads or anything like that. So that's exactly what we wanted to see. Okay, so I'm going to come in here just with a little bit of isopropyl alcohol, just while that flux is still warm, and just give it a little bit of a clean up here. Try and clean any of that extra gunk off here. And then at this point, if we were going to be attaching another chip, then I would clean this up with that solder paste, but we'll save that for the second video here. We put some fresh solder on, try and clean this off, and then get it ready to apply on. But for now, that's going to be good enough for this. So I am going to clean up the chip though, so let's move this out of the way here. Okay, I got my chip here, and it's actually quite sticky because it's covered in flux. So I definitely put way too much of it on. So what we're going to do is just try and give it a little bit of a scrub here with some isopropyl. Just helps because we're going to be putting this into the X-Gaku, and it's nice not to gunk this up if we can. So I try and stay as much away from the legs as I can. Just don't want to get any of these fuzzies stuck in them, but it's a bit of a trade-off here between fuzzies or flux. So flip it over here. Use some of this leftover isopropyl here. perfect. It's definitely looking a lot cleaner now here, if I can focus to look at it. But yeah, looking a lot cleaner. And so one trick here too, while it's a little bit wet, if you have too much isopropyl, is if you hit this with a little bit of heat, it will evaporate very quickly. So we'll just hit it with just a little bit here, and you can see how fast it evaporates here. Just clean that up. Perfect. Now that we've got our chip off, the next step is going to be to put it into our XGECU or whatever firmware reader you're going to be using. So I brought mine here because I want to just quickly show or point out here on the layout here. So you'll start with this one where it says IC first. So that's like the first half of it. So if you are using a chip that's not going to go, the full way, it actually starts up here. And you can see here, interestingly, so there's this little marker indicator which indicates the top left of the chip. So usually by intuition, this would go in this one, but on the XGECU, actually, just to quickly call it out. So it goes in whatever the top of this is. So the bottom pins would go in here, and then however many high they go, top one is on this left side. So you have to keep that in mind when you're orienting it with the adapter. So if I bring my adapter here, I've got this SOP 8-1 right here. You see it's just got 8 pins. So what we're going to be doing is we're going to be slotting it in here to the top one, right? So we're going to need our orient our chip. So the pin is right here. So let's do that right now. First, make sure our pin marker is in the right spot, and then we'll pop it into the XGECU here. Okay, so I got my socket here ready to go. So just one quick thing to call out to here is you'll see a measurement on these sockets. So this is for a 200 to 209 millimeter SOP 8, and that's the right measurement for this. It's the most common one I see, but just keep that in mind because you'll get a bunch of adapters that can do SOP 8, and there'll be different measurements. So if it's not fitting, you probably got the wrong measurement. So we're going to need this. I just need to think about how to orient this. So it's going to go, if it's going this at the top, then we need the pin indicator chip, the top one, that circle to go there. So I'll just grab my chip here and try not to bump the camera here, and we'll just gently put it in. So actually the way that this works before I put it in is if you push down on the top of this adapter, you'll see it opens up these clamps. And then with those open, we just slide the chip in and then hold it down in place, and perfect. It's locked in place there. So looks like we got a good connection on those pins. So now we can slot this into our XGECU. So if I bring this here, got this lever here. When it's up like this, all these connections are open. So we're gonna make sure these pins are all the way up at the top here. Slot it in, pull this down, perfect. And now we're ready to plug this into the computer. Okay, I'm over at my computer now, and the first thing we're going to need to do actually is install MiniPro. So I've got the repo for this open. This is an open source tool that we're going to use with the XGECU. So XGECU actually has its own software as well, but it's only released for Windows, so you got to use Wine and a bunch of other stuff if you want to use it on Linux. And Matt Brown actually did a whole good video about why it's not great. I'll link that down below, actually, if you want to check it out. And he goes into some more details about it. But anyway, shout out to him for pointing this out to me, and also for David Griffith, the person that has released this, because it makes using XGECU on Linux so much easier. So I'll drop a link to this repo down below. I've already installed it, but I'll run through and show what you need to do here. So if you scroll down here, actually, to the README here, and most of you are probably running on Debian. If you're not, you're probably going to maybe have to do some figuring out yourself if you're not one of these distros. So I'm on Ubuntu. If you're on Kali Linux, you're on Debian. So you'll need to run this command here. So I've already run it. Then it's as easy as just checking out this source code here. So you clone this, cd into MiniPro, and make. So if you have a T56, you need to download and install the algorithms for XGECU's official software and then run this make. So to call that out, it's a .xml file. And to get to that, actually, if you go into branches here, and then you go into this Radioman V-T48-original, there is this algorithm.xml. So you'll need to download this separately and put it in that mini pro folder, because if you want the newest branch, it's not included in the newest branch, I believe, because there are some copyright issues. So we'll go back to master branch here though. So essentially all we just need to do is clone this and then run these make commands and then this final one, and then you can just plug in your xgeku and we can let it rip. So let's hop over to the terminal now here, and first thing I'll do, so once you plug in your xgeku, is you want to run mini pro -t, and then make sure you see your programmer connected. So my firmware is out of date. I'm just going to run with it though. This is totally fine. We're like one step out, but everything's working fine for me. So I'm just going to leave it for now, but you'll want to make sure that you see yours. So then the next thing we need to do is we need to find the name of the chip so it knows what algorithm to use to read it, or how to communicate with the chip. So what I do is I usually just take a really close-up picture of the chip with my phone camera. So if you have a microscope, you can use that as well, but honestly, phone cameras are so good nowadays. You can get high-res pictures that are as good as really expensive microscopes just on your iPhone or your Android. So here's a picture that I took actually just now of that chip. And what we need to do now is run mini pro -L, and then just search for the first few markers on the chip. So for me, it is this QH32B. And you'll see there's a few that it finds. It's kind of like grapping on that basically when we search for it. And ours is in this SOIC8 package, so SOCI8. Also sometimes it's like SOP8 or something. So what I'm going to do is I'm just going to copy this actually. I'll copy this string here. Copy this string. And then now we're going to go on mini pro, and it is -P. So we're going to tell it what chip it is. So I've actually got this here, and I'm going to take the -Y out actually here. I'm going to call mine firmware.bin, and I'll show you what happens without the -Y. So we'll go -R, firmware.bin, and you'll notice for whatever reason with this chip and xgeku, I couldn't get it to negotiate at the start. So there's like a check that it does through SPI where it checks the chip ID and makes sure it matches, and then if it doesn't read. So I don't know if it's something with the xgeku or experimental or whatever, but I was finding that it wouldn't negotiate it, but it will still read. So what I'll do is I just use the -Y here to force that. So if we actually go in here, and then we'll just hit -Y to force it. Actually, it needs to be here, -Y, and we'll let it read. So it's reading for a little while here now, and then if we just go file, we call it fw.bin. Perfect. And if we go strings fw.bin, see there's a whole bunch of stuff there, and some of them are we got actual text. It's not just junk here. I can see there's some actual text, Android and stuff there. So we'll clear this away here, and then for a real good sanity check, we can run binwalk on it. So we'll go fw.bin. And perfect. Okay, so we could go ahead and extract this now, and that shows how you could go and extract your firmware. So the whole process, right from start to finish, of taking off the chip, pulling it off, putting it in the into the xgeku, extracting the firmware, and now we can go and do some firmware analysis or reverse engineering. So I hope you enjoyed this video and you learned something from it. If you did like it and you want to see more like this, these instructional style videos, then please make sure you are subscribed to my YouTube channel. It helps out a lot. I'm going to be trying to put out a bunch more of this style of videos in 2026. So again, thank you so much for watching. This has been Digital Andrew, and I hope you go out and try this out yourself, and let me know in the comments if you do.